Sorry guys, that video got cut a little bit short. So like I said, if you break this up into fours, you're going to see that each one is worth 3 because 12 divided by 4 is 3. So I would label each one of these sections as a value of 3. And again, if I added up the total, 3 plus 3 plus 3 plus 3, that's going to equal 12, which is what the total unit is. So if I want to find out what 3/4 of the total would be, I would take 3 parts, just like you did with the array, and I would add them up. So I have 3 plus 3 plus 3, which would give me 9. Or where does the multiplication comes in? Because I told you we were multiplying. We know that multiplication is repeated addition. So I could easily do 3 times 3, which is going to equal 9. So what does that mean? 3/4 of 12 equals 9. That's how I'm going to word it. And don't forget, this word of means multiply. You're right. So this is 3/4 times 12 would equal 9. So let's try a couple of them together. So the first one, 4/6 of 18. So the first thing you need to do, draw your tape diagram. So go ahead, in your notebook, draw your tape diagram. Can you guess what I'm going to label the tape diagram? What my total value is for the set? You're right, 18, because that's what this number is. So I'm going to label that as 18. That's what my tape diagram is equal to. So now I have to break this tape diagram up into sections. Do you remember how to do that? Right, look at your denominator. So if my denominator is 6, I need to break this up into 6 parts. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So there's 1 part, 2 parts, 3 parts, 4 parts, 5 parts, 6 parts. And even though we know that they should be equal, if we can't make them all equal, we're not going to stress over it. That's okay. So now how do I find out what each of these parts is equal to? Well, remember, we have to divide. So I'm going to take my total amount, 18, and I'm going to divide it by how many groups I created. So I created 6 groups. So I'm going to do 18 divided by 6. So I know 18 divided by 6 is 3. So that means each of these boxes or parts is going to equal 3. And again, it makes sense because if I add it up, 3 plus 3 plus 3 plus 3 plus 3 plus 3, I'm going to get a total of 18, which I know is my total value. So now I want to know what 4/6 of 18 or 4/6 times 18, what that's going to equal. So I have to go to all 4 sections, 1, 2, 3, 4, and I could add them up. I could say 3 plus 3 plus 3 plus 3, or I could say 3 times 1, 2, 3, 4 equals 12. So I know that 4/16 of 18 is going to equal 12. Okay? All right, let's try another one. If I did this one, 2/3 of 15. So if I look, I know I have to do a tape diagram. So go ahead, you do your tape diagram, hit pause, and let's try and do this whole problem on your own and see how far you get, and then we'll come back and compare answers. Okay, so hit pause. Did you hit pause? All right, I'm going to try it. So now I'm guessing you're back because you hit paused and you solved it. So there's my tape diagram. I'm going to make my tape diagram have a value of 15. So that's how I represent my tape diagram. I have to break this up into parts. So looking at my denominator, this tells me I need 3 parts. So there's my 3. There's 1/3, 2/3, 3/3. I have to figure out what the value of each of these thirds is. So I have to do a division problem. I'm going to do the 15 divided by the 3 groups. So that tells me that each of these groups or each of these thirds is worth 5. So if I want to know what 2/3 of 15 or 2/3 times 15, I'm going to look at 2 of the groups and I'm going to add up what I have. So I have 5 plus 5 equals 10, or I could do 5 times 1, 2, same thing, equals 10. So 2/3 of 15 equals 10. Okay, let's do this one. You guys try this one on your own. Hit pause, try it on your own, and then come back and compare what you have to what I do and see if it comes out the same. So that way you know how you're doing. Okay, so hit pause. All right, let's give it a shot. So again, I'm going to create my tape diagram. So here's my tape diagram. It's going to have a value of 35 because that's what my total is. I'm running out of room here. Hopefully I don't write on my wall. So there's my 35. I have to break it up into parts. So looking at my denominator, I know I have 7 parts. So I'm going to break it up into 7. 1, 2, 3, 4, 5, 6, 7. Should have 7. 1, 2, 3, 4, 5, 6, 7. Okay? I have to figure out what each of these parts is worth, so I had to divide. I had to do the 35, the total, divided by how many parts? I have 7. So that tells me that each of these parts is worth 5. So I'm going to fill in the 5. 5, 5, 5, 5, 5, 5, 5. So if I want to know what 3/7 of 35 is, or 3/7 times 35, I have to look at 3 of the sections, or 3 of the parts, which is right here. So to find that, I could add 5 plus 5 plus 5. Those are my 3 sections. That's going to give me 15. Or I could say 5 times 3 equals 15. Either way, it doesn't matter. So 3/7 of 35 equals 15. Okay, so that's a tape diagram. So now I'm going to show you the good old-fashioned way, the standard algorithm. So I want you to get your notebooks out again, and you're going to copy down some new notes on how to solve multiplying by a fraction and a whole number using the standard algorithm. Okay, so these are the notes. Whoops. Okay, so take a minute to copy down the notes, and then I'm going to go over them. Okay, so now you have these notes. This is the same problem that we just did, so that way you could kind of see how it all equals the same thing no matter how you do it, whether you use an array, a tape diagram, or the standard algorithm. So to multiply fractions by a whole number, what you need to do, this number is a whole number, it's not a fraction. So it has the same value if we put it over 1. So it just makes it easier to have both of them as fractions. And later on, we're going to be multiplying fraction by fraction, so this will make more sense. So when you multiply the fraction by the whole number, you start by creating both of them to be fractions. Then you're going to multiply your numerators, which is your top number. And then that's going to become your new numerator for your answer. So if I took the 3 times the 12, which is both of my numerators, 3 times 12 is 36. That's my numerator for the answer. Then the third step is I'm going to take the denominators and do the same thing. I'm going to multiply them. So my denominators are the bottom numbers, 4 times 1. So if I do 4 times 1, I get 4. So now my answer is 36 over 4. But the problem is that's an improper fraction. We can't leave them like that because my numerator is larger than my denominator. So we have to make it into a division problem. So I take this 36 divided by 4, and that becomes 9. So 3/4 of 12, or 3/4 times 12, equals 9. So if you went back to the one that we did for the tape diagram, you're going to see it was the exact same answer for what we did. So let's say we had another one. Say we had what was 5/7 of, let's say 35. Okay, so 5/7 of 35. That's kind of a tricky one. You could do an array, but you'd have to do the 35 dots. You could do a tape diagram, which is fine. That works out well. Or we could do the standard algorithm. So to do the standard algorithm, first thing I'm going to do is put that over 1. Now I have to multiply my numerators. 5 times 35. Well, I don't know 5 times 35 off the top of my head, so I'm going to do it over here on the side. 35 times 5. 5 times 5 is 25. Put the 5, carry the 2. 5 times 3 is 15, plus 2 is 17. So my numerator is 175. It's a pretty big numerator. And now I multiply my denominators. 7 times 1. 7 times 1 is 7. So 175 over 7 is an improper fraction, so I have to fix it. I have to do a division problem. So I don't know what 175 divided by 7 is, so I'm going to do it on the side. So 7 goes into 17 2 times. 2 times 7 is 14. 17 minus 14 is 3. 3 is smaller than my 7. Bring down my 5. My new division problem is 35 divided by 7. So 35 divided by 7 is 5. 5 times 7 is 35 with a remainder of 0. So that means that 5/7 of 35 is 25. Okay? So that's how we solve these using our standard algorithm. Again, if you love doing math facts, multiplying and division, this might be the best way for you to go. If you like to break it up into smaller steps, so that's more visual, the tape diagram or the raise might be the best way to go. But whatever works for you, works for me. Just don't forget to show your work and share your work, okay? So you can work on the practice that's attached to this assignment, and good luck with everything. Okay, guys? See you soon. Bye-bye.